Welcome back, math fans. So we're going to graph. We're going to start looking at equations of functions, and then we're going to graph them. So I'm just going to read here. A graph can be created from any form of the equation of a linear function. Okay. So given a graph in general form, so what does general form mean? If it's in the form of ax plus by plus c is equal to 0. So given a graph in general form, how do you graph it? Well, you change it to another form. General form's really, really bad. So if we're given something in general form, we try to change it to slope-intercept form. Fair enough. Seems plausible. We've done that, actually. So given a graph in point-slope form, we plot the point and use the point to find a second point. So point-slope form is actually nice. It gives you one point on a graph and it gives you the slope. Huge question. How many points? It's almost like a joke. How many points does it take to graph a line? There we are. So I should improve my delivery. How many points does it take to graph a line? The answer is 2. You just need 2 points to graph a line. And I know that we've been messing around with some equations. So here, example 5. And by the way, if you can come up with xy points that satisfy this, you can just graph it in your head. Really tough to do. Perhaps we'll save that for class. We're going to graph this equation. This equation is in some form. It's actually in general form. But if I choose to graph an equation, I want it to be in a nice graphing form. The nice graphing form is y is equal to mx plus b, is it not? Slope-intercept form. Basically what I'm going to do is I'm going to isolate my y to one side. So we're going to be well practiced. I am going to subtract 2x to both sides, subtract 1 to both sides, and I get y is equal to negative 2x minus 1. Remember that this number here represents my y-intercept. My y-intercept is negative 1. The coefficient in front of x represents my slope, which is negative 2. So that means that I go over 1 unit in the x direction, but I go down 2 units in the y. Or alternatively, you go down 2 units in the y over 1. I mean, there's actually 4 different combinations that you can do, but either one, that's what I'm going to do. So I'm just going to count down 1, 2, and over 1. I end up with a second point. I ask myself, how many points do I need to graph a line? Answer is 2. So there. I start graphing my line, and there I have it. Those are my 2 points. Please use a ruler. Please make sure that your lines have arrows at the end. All right. That wasn't so bad. All right, let's move on. Here's another equation. Graph it. Yuck. I like stuff in slope-intercept form because it's the best to graph. Now it's going to take some time. So I'm just going to isolate y's to both sides, isolate y to the left side. So I'm just going to subtract 3x to both sides, and then I'm going to add 8 to both sides. And then I'm going to choose to, I'm just going to rewrite my equation again. Now you notice I rewrite my equation because this signifies a different thought. So now I'm going to divide both sides by 4 because the condition of a slope-intercept form is that the coefficient of y is 1. So I'm going to annotate here, subtract 3x to both sides, add 8 to both sides. So here I'm going to divide both sides by 4. End up with y is equal to -3. Okay, yeah. Whew. So I'm going to distribute my division. There we are. And I feel we're very close to home now and very close to the answer. So we get y is equal to -3 over 4x. And then plus 8 divided by 4 is 2. So I graph 2. There we are. Graph 2. And my slope is -3 over 4. So that means that I'm going to go down 3 units and over 4. So I need a second point. So now I'm going to go down 3 units. 1, 2, 3, and over 4. 1, 2, 3, 4. So I have another point at 4, -1. All right. I think you've seen enough here. There's no real point in doing C. I'm going to jump to another type of equation. So we really need just 2 points. Oh, gross. This one. By the way, what is this thing called? It's called the point-slope form, or the slope-point form, I forget. And I believe it is y minus y1 is equal to mx minus x1. So why do we write this? Well, very simply, m is the slope. x1, y1 is a point. So how do we graph this? Well, I'm just going to maybe pick this out. So here, if I look up, m is my slope. So m is equal to 3. 3 is my slope. My point that is on my graph. Now, here's a tricky thing. My point, notice how it's y minus y1, x minus x1, right? So my point is actually going to be 1, because my x value here, it's x minus x1, so x1 would have to be 1, and my y1 is 2. I know what you're saying, that it is weird because it's the negative of what it appears, and you're absolutely right. It is the opposite of what you're going to think just because of the way this form is written. Regardless, I have a point 1, 2, right there. There's 1 point. And so there's a point on my line. How many points do I need? 2. So simply, here's my slope is 3. So that means that if I go up 3 and over 1, right, for a slope, so up 3, 1, 2, 3, over 1, there's another point. Wow, that was actually far easier than I thought. Bet you were a little bit worried. You need 2 points. This is the last one I'm going to do. There's no sense in beating this up because it's more important to think about this rather than to repeat. My slope. That's how I can find my slope. My slope is -1/2. So that means that I go down 1 unit and over 2. Rise over run. However, my xy values, right? So here's my point. And I'm just going to rewrite this point out. There's the standard form. And it helps, or there's the form that's given. And it really helps me to think about, oh yeah, it's the opposite of what it appears. So it looks like y is 3, but my point is actually going to be -3. You would think that your x value is -4, but it's actually 4. So, what do I know? I know I have a point at 4, -3. What do I know? I know my slope is -1 over 2. So I'm going to count down 1 over 2 units, and I have another point there. Really wish I had a ruler here. Not that you guys have a ton of time to watch me struggle, but I'm just going to say, let's draw a shape. And let's see if this works. Definitely not. All right. So you'll have to stick with me, but I'm just going to draw my line through there. There's no need to extend this line very long, but it should give some shape to it.